For Homelinks 4-8, we're continuing to talk about money. There's a little family note there that says that today we solved multi-step number stories involving multiplication, addition, and subtraction of money amounts. So you should be explaining a plan for solving each of these to an adult before you actually solve it. Mr. Russo is buying equipment for his baseball team. Use the table at the right to answer questions about his purchases. Mr. Russo needs 9 helmets and 8 gloves. How much will they cost in all? So 9 helmets are $22 each. 9 times 22. 8 gloves. 8 times 35. Okay, I'm going to do 9 times 20 first. 9 times 2 is 18 plus 0 is 180. And then 9 times 2 is 18. Add those up. 198. 8 times 30 first. 8 times 3 is 24 and 1 0. 8 times 5 is 40. So 280. I'm going to add those two costs together. I get 8, 7, carry the 1, 4. $478. Mr. Russo wants to buy 6 bats for his team. How much more would it cost for him to buy 6 metal bats than 6 wooden bats? So let's see, metal bats are $74, wooden bats are $49. So I'm going to do 6 bats times $74. I know that 6 times 70, 6 times 7 is 42 and 1 0 is 420. 6 times 4 is 24. So the metal bats would cost $444. The wooden bat, 6 times 49. I do 6 times 40, I get 240. 6 times 9, 54. Add those up, I get 294. So how much more I need to subtract? 444 minus 294 equals 0. I cannot do 4 minus 9, I borrow. 14 minus 9 is 5. $150 more for the metal bats than the wooden bats. Mr. Russo buys 5 wooden bats and gives the cashier $300. How much change does he get? 5 wooden bats times $49 each. I know that 5 times 40, 5 times 4 is 20, and 1 0 is 200. 5 times 9 is 45, so that'd be $245. He gives the cashier $300, so 300, take away the 245 to figure out how much change he would get back. $55. If the cashier only has $10 bills and $1 bills, what are 2 ways he could make Mr. Russo's change? So maybe he would give 5 $10 bills and 5 $1 bills for a total of $55. That's one way. A second way that he could do it, because it says 2 ways, might be 3 $10 bills, which would be $30, and 25 $1 bills. You could also say maybe 4 $10 bills and 15 $1 bills. Or 2 $10 bills and 35 $1 bills. Down at the bottom, factors. So I should see some factor T's. I want to start with 21. I know 1 times 21, 2, it's not an even number. 3, if I do 2 plus 1, that does equal 3. 3 can go into 21 7 times. 4 is not a factor because 21 is odd. 5 is not a factor because it does not end in 0 or 5. 6 is not a factor because 2 and 3 aren't factors. And 7 is listed, so my factors of 21 are 1, 3, 7, and 21. Factors of 40. 1 times 40. 2 is a factor because 40 is even, be 2 times 20. 3. If I add the digits, 4 plus 0 is 4, and 3 is not a factor of 4, so 3 is not a factor of 40. 4 is a factor of 40, it'd be 4 times 10. 5 is a factor because 40 ends in a 0, 5 times 8. 6 is not a factor because 2 and 3 are not factors. 7. I know that 7 times 5 is 35, and 7 times 6 is 42. So 7 is not a factor, and 8 is listed, so I'm done. Factors are 1, 2, 4, 5, 8, 10, 20, and 40. Factors of 36. 1 and 36. 36 is even, so 2 is a factor. You could do 36 divided by 2 to figure out the missing factor. It would be 18. 3 is a factor because 3 times 12 is 36. 4 is a factor. 4 times 9 is 36. 5 is not a factor because 36 doesn't end in 0 or 5. 6 is a factor. 6 times 6 is 36, and I am done. 1, 2, 3, 4, 6. I only have to write the 6 one time. 9, 12, 18, 36. And last, 45. I do 1 times 45. 2, it's not even. 3, I do 4 plus 5, I get 9, which is a multiple of 3, so 3 can go into 45. Do 45 divided by 3 and you get 15. 4 is not a multiple of 45, or a factor of 45, because 4 times 11 is 44. 4 times 12 is 48. 5 is a factor because 45 ends in 5. It'd be 5 times 9. 6 is not a factor because 2 and 3 are not factors. 7. 7 times 6 is 42, so 7 is not a factor. 8. 2 and 4 are not factors, so 8 is not a factor, and 9 is there. So I have 1, 3, 5, 9, 15, 45.